Hi guys, welcome back to another episode of Project Explained. Yeah, it's been a while, but we do what we do, and kindly guys have been one of you, a subscriber called Graham from Nigeria. I think he's a student in Nigeria, and he had asked me something about survey, and I wanted to do a voice note for him. So that's what I'll do. I'll share a voice note that I'm going to send him so that everyone can actually benefit from it. So it will be a voice note, and you guys enjoy. Yeah. Okay. So this will be the voice note that I'll be sharing in the gram, and it's a detailed thing because he wants to know about survey, and this is what I'm gonna do for him. So hi Graham, here are the common survey methods used in bore drilling. One of the main one is geological survey. Yeah, so this is where analysis of the rock formation and soil layers is done to figure out the best drilling location. So you start with geological survey, then there's another method called geophysical survey, and this is where you use tools like resistivity meters or seismic methods to map out underground water bearing formation. So note, geological survey, this is where you get to analyze the rock formations, and the geophysical survey, this is where you get to see the groundwater bearing, and that you have to use either seismic, PKWT, or the VES method, which is a vertical electrical sounding. So sometimes an hydrological survey is done to understand the water flow and the aquifer characteristics. Each of these methods give you different insights, and this helps pinpoint the best drilling spot. So you have to combine both of the geological survey and the geophysical survey methods to get a detailed and an accurate results for you to get the best drilling points. So I get you've noted that there is a geological survey and the geophysical. So let's go into the geophysical survey, which mostly is done, and we're going to start with the sounding first method. Yes, and this is a geophysical method. Yeah, that helps to investigate the subsurface layers by measuring how electrical resistance changes with depth. You get that? How electrical resistance changes with depth. So essentially what you do is you place electrodes into the ground and measure the resistance at different depths. This is done by varying the spaces. That is, these those electrode poles, or those electrode what do you call them? Electrode metal pieces that you move at different stages so that you can get a variance. So by varying this, the spacing of the electrodes, you can create now a profile of how resistivity changes with depth. So when you vary 10 meters, it means you've done 10 distance. Okay, let me get it back. If you vary the electrode 10 meters horizontally, it means you also varied 10 meters vertically. So this means by varying the space of the electrodes, you can create profile of how resistivity changes with depth. This helps identify different layers, like clay has its own resistivity, then sand or gravel, and now you'll be able to locate the aquifer. It's pretty useful for figuring out the depth and the thickness of water bearing formation. So that's vertical electrical sounding, and I'll maybe give you a photo of a VES being done. Then we go to the second one, that is called the seismic method. Sometimes it's called a shot because basically it's like a blast. So in seismic methods, they're quite fascinating, and in bore drilling, the seismic method involves sending energy waves into the ground and then measuring how these waves travel through different subsurface layers, and there are a couple of main types, the reflection seismology and the reflection seismology. So note, there is reflection seismology and the reflection and the reflection. I think you're getting reflection and the reflection. seismology. So in reflection seismology, the energy waves bounces off different rock layers. So once you do the blast, when you're doing the seismology, and specifically on the reflection seismology, the energy waves, once you do the blast, bounces off the different rock layers, and by analyzing the reflected waves, you can map out the boundaries of those layers. Then in the refraction seismology, now the refraction seismology, once you blast, the waves bend or reflect when they hit layers with different densities. So it will behave, the curves will behave once it hit a hard rock, a soft rock, it will give you that what is it called, that wavelength or the graph, and you can use that information to figure out the depth and the type of those layers. So seismic methods are really powerful, and really not rare, they are really powerful for pinpointing aquifers and understanding the geological structures underground. So I think that's good. The seismic method is like actual blast, it's called a short method. Then you go to the PQWT, and this is also called imaging. So this method stands for Pulse Quantum Water Test. Pulse Quantum Water Test. Yes, and it's a kind of advanced technique used to locate groundwater. And this involves using a specialized instrument that emits pulse electromagnetic waves into the ground. Yeah, so the imaging part, that's where you get the electromagnetic waves into the ground, and by analyzing by analyzing the response of these waves, the PQWT method can help identify the presence of groundwater. The depth, sorry, by analyzing the response of these waves, the PQWT method can help identify the presence of groundwater, the depth of the water table, and even the quality of the aquifer. Yeah, that's very advanced, and you actually get an imaging and see how the rock formation looks. It's often used because it's non-invasive and gives pretty accurate pictures of the subsurface water condition. Yeah, that's how there is an image that you get, and maybe I'll share with you with the image, and then there is the traditional method. So we've done the vertical echo sounding, and we also covered the seismic method, and we've covered the image method, which is the PQWT. And now we go to the ancient, which was called the water witching. Yeah, back then when we didn't have this technology of testing or doing the survey, there was something what was called water witching. Yeah, or sometimes it was called dosing. Yeah, in some countries they call it dosing. So it's a more traditional and intuitive method. It typically involves using rods or a forked stick, and the person holding them walks over the ground to detect the presence of underground water. While it has been used for centuries and some people swear by it. Yeah, so it's not scientifically proven, but tends to be more subjective. So it's not scientifically proven. Yeah, so that's why it's called water witching. Yeah, so you know what witches do. So in areas with complex geology, or where precise information is needed, water witching cannot work, and it's not actually very reliable. So as the modern scientific methods like PQWT, seismic, or the electrical sounding. So having said that, it can still be useful to supplement the tools. You can go somewhere and you don't have tools, especially in real-world traditional settings. It's often combined with other methods to confirm. But what I know, especially in Kenya, most of the hydrogeologists usually start with water witching. It gives them the zone where, you see, when they go with those two rods, where the two rods come together, the zone and area, that's where they specifically do the survey. So I know you'll be asking yourself, which is the best method to use? Okay, I would say there's no best method when it comes to survey. All methods are important, but what is important mostly is on the formations that you want to do survey from. So it really depends on the specific conditions of the site and the goal of the drilling project. So the site may be in a basement area, the site may be in a volcanic area. So you may choose either. So for example, if you need to do a detailed information about a different subsurface layer and their boundaries, you obviously go with Seismic. So Seismics are incredibly effective. On the other hand, if you want a more direct and quick and non-invasive way, fast and you get good results, yeah, the only way to locate groundwater on that, you can go for PQWT method. Can be very useful. Similarly, the VES or the vertical echo sounding is great for understanding the layers or and depths of the aquifers. So you see, it is not specific. So as you see, it's not specific. There's some places you'll need to use Seismic, the others you'll need to use PQWT, and the others you'll need to use the VES. But the best combination mostly is usually the VES and the PQWT, because the Seismic is not very common. It's not very common. So in practice, many projects combine multiple methods to get most comprehensive pictures. So the best method really comes down to what you need for a specific situation. So I think that has been it, and I hope it is helpful. You can go deeper into your notes and read about vertical echo sounding. You can also go read more about PQWT and read more about the seismic method, the reflection and the reflection method in the seismic. So knowledge is abundance. Go check from your notes, from your textbooks, from the internet and everywhere. But I think I've broken it down to the most common one, the 4 common ones, but the scientific ones are 3. That is the seismic, vertical echo sounding, the PQWT, water witching. Okay, I can tell you it's done probably to zone an area, but not to you can't get the depth using as water witching. You can't know the resistivity of the rocks and the layers of the ground with water witching. So you need to invest in the scientific part of it. So if you found the ball has been drilled, as you see the grammar, you can ask for the hydrological survey report, and maybe you can read through it and you will see the results of what method they used. If it's the VES, you'll see the resistivity records, you will see which rock according to the results. You'll be able to see. If it's a seismic, you'll be able to read the graph, and if it's the PQWT, you'll be able to see the picture or the image of the ground and the zoning and the correlation, and you'll be able to know which rock is this, where water is, all that. So I think that's it. And if that has been helpful, kindly guys, if you've not subscribed to my channel, please subscribe, like the video, and also comment. Let's get, I think that's it. Thank you guys.